Good morning, friends. Today we discuss about the topic bioinsecticides. Bioinsecticides. These are the insecticides derived from such natural materials as animals, plants, bacteria, and certain minerals obtained from biological agents. The pathogenicity of microbes against different pest species has been widely utilized in the synthesis of bioinsecticides. Many of the bacteria, viruses, and fungi are highly specific for particular pest species and have served as the fundamental agents for several integrated pest management programs. For example, the bacterial agent we all know Bacillus thuringiensis has been used for the control of lepidopterans, Agrobacterium radiobacter for treating crown gall disease. Viruses like nuclear polyhedrosis virus for controlling hymenopterans and lepidopterans. Fungi like Neozygitus floridana for controlling cassava green mite, Entomophaga praxibuli for controlling grasshoppers. Many of the bacteria, viruses, and fungi are highly specific for particular pest species and have served as the fundamental agents for several integrated pest management programs. Advantages of using biopesticides. First one, biopesticides are usually inherently less toxic than conventional pesticides. Biopesticides generally affect only the target pest and closely related organisms, in contrast to broad-spectrum conventional pesticides that may affect organisms as different as birds, insects, and mammals. Hence, they are considered to be much safer for human and non-target animals. Biopesticides often are effective in very small quantities and often decompose quickly, resulting in lower exposure and largely avoiding the pollution problem caused by conventional pesticides. When used as a component of integrated pest management, that is IPM programs, biopesticides can greatly reduce the use of conventional pesticides while crop yields remains high. Although microbial pathogens are potentially effective substitutes for chemical insecticides, their efficiency needs to be greatly improved at a lower cost to compete with synthetic insecticides. Currently, bioinsecticides constitute only up to 2 to 3% of degradation by solar radiation. Bioinsecticides constitute only up to 2 to 3% of the insecticides market share because of their narrow spectrum of toxicity and sensitive degradation by solar radiation. They are applied to much higher rates than some of the newest synthetic insecticides. But their presence for a shorter period in the environment makes it necessary to perform several applications to achieve adequate control. Even though these are very specific in their mode of action, they are slow in their action. The timing of the application is relatively critical and is highly influenced by environmental factors. A great variety of commercial bioinsecticides are based on the entomopathogenic bacterium Bacillus thuringiensis. It is a rod-shaped, gram-positive bacterium that forms spores and found in the soil and on plants. This bacterium was discovered to have pesticidal properties if consumed by the larvae of specific insects. These insecticides represent more than 90% of the microbial insecticide market and are primarily applied in organic agriculture. But Bt insecticides rely on the activity of proteins that disrupt the insect's midgut epithelium, causing larval death. They do not affect adult insects. Bt insecticides may contain different Bt strains expressing different cryogens. Susceptible larvae that ingest the toxin are not killed immediately but die over the next few days. Larvae that survive the toxin may be more susceptible to other environmental stresses such as cold temperature or low levels of botanical insecticides. This makes biopesticides an important component of IPM programs. The strain of Bt characterized so far affect members of three insect orders, namely Lepidoptera, Diptera, and Coleoptera. These are some pictures of the bioinsecticides. Okay, thank you.